Assalamu alaikum wa rahmatullahi wa barakatuh. Today we will begin a new chapter, which is chapter 4. But before we return back to your book, we will discuss this section from outside. I make a photocopy from it and I will send it for you as a PDF on the model. We discussed this section since number of ways is not clear in your book, especially in chapter 4. But when we finish this section, we will return back to section 4.1 in your book in order to discuss the probability theory. First of all, introduction. You can read the first section, and I will begin in the second section, combinatorial methods. Here we have a beginning. In the beginning, introduction in many problems of statistic, we must list all the alternatives that are possible in a given situation, or at least determine how many different possibilities there are. In connection with the latter, we often use the following theorem, sometimes called basic principle of counting, or the counting rule for compound events, or the rule for multiplication of choices. In this book, in this section, we will have some theorem, but we don't deal with the proofs. These are reals. You don't have to know the proof, but you must know the procedure of this theorem. If an operation consists of two steps, of which the first can be done in N1 ways, and for each of these, the second can be done in N2 ways, then the whole operation can be done in N1 by N2 ways. Here, the first example. Suppose that sometimes someone wants to go by bus or by train or by plane on a week's vacation to one of the 5 east north central states. Find the number of different ways. You can go to New York by a bus or by train or by plane. You can go also to Ohio, suppose by train or by plane or by a bus. Here, number of ways. You must multiply number of states by number of transportation. 5 by 3, 15 ways. We have also a tree diagram like this. You can see it in the next page. Here, Ohio, Indiana, Illinois, and Michigan, Washington. You will have each state has a 3 transportation: by bus, train, and plane, by bus, train, and plane, and so on. You count 3 plus 3, 6, by plus 3, 9, plus 3, 12, plus 3, 15. This is the way you have to solve it by a tree diagram. Here, second example, you will have it. Second example, here, how many ways or possible outcomes are there when we roll a pair of dice? يعني زوج من الحجر النرد. كلنا بنعرف انه حجر النرد له 6 أوجه, 6 faces, 1 red and 1 green. Here, how we can calculate it? Number of faces for the red one will be 6, and number of faces for the green one will be 6 faces. Then you will have 6 by 6, 36 ways. 36 ways. Here, second theorem. Suppose you have not 2 steps in one, in 2 k steps. If an operation consists of k steps, on which the first can be done in n1 ways, and the second one in 2 ways. Second one in 2 ways. First one in 1 ways. A third one in 3 ways, and so on, 4 and so on. Then number of ways will be n1 by n2 up to nk ways. Suppose you have here third example. In how many different ways can one order soup, sandwich, and dessert? Dessert means a sweet or a fruit. And drink means hot or cold drink. If there is a choice of 4 different soups، يعني عندي نوع من 4 أنواع شوربة، ونوع من 3 أنواع ساندويشز، نوع من 5 أنواع ديزرت يا تحلية أو فواكه، and for one of 4 drinks ساخن أو بارد. Now your total number of ways will be 4 by 3 by 5 by 4, 240. Here we have an important example, which is number 4. In how many ways can one answer all the questions of a true-false test consisting of 20 questions? Suppose you have an exam, which is a true-false exam. You have a 20 question. In how many ways? True-false means you have 2 answers, but you don't know which is correct, true or false. Suppose the first student answer the first question true, the second student answer it false, and so on. You will have 2 choices for the first question, second question, 2 choices, and so on till the 20th question. Then you will have 2 by 2 by 2, 2 to the power 20. You will have 1,048,576 ways. We will have another question. Here, question. Example. Here, example, suppose you have an exam of 30 questions of MQ questions. Each question has 4 answers. A, B, C, D. In how many ways? Ways can you answer this exam solution? First of all, you have first question, second, third, till 30. You have 4 answers: A, B, C, D. Here you have A, B, C, D. Here you will have A, B, C, D. Also, here you will have A, B, C, D. Then, number of ways will be: the first question has 4 choices. The second will has 4 choices. The third 4 choices, and so on. You will have 4 to the power 30, which is certain number. I don't want it ways. Returning to returning back to this question, now we will discuss the permutation. The third theorem will be a number of permutation, which is tabadil in Arabic. Number of permutation of n distinct object n factorial, which means n factorial. You have here n factorial means n1 multiplied by n here n by n minus 1 by n minus 2 multiplied by n minus 3, and so on till 2 by 1. This is the meaning of n factorial. N factorial here, but the order is important. The order is important. Here you will have in how many ways? Different ways can 5 starting players of the basket team be introduced to the public. 5 factorial, 5 by 4 by 3 by 2 by 1. Also, you can see it in if you have a school and you have children. Suppose 5 children and they are sitting suppose example suppose we have 6 children, and you have 5 chairs. In how many ways can they sit, they sit. Solution. Here, suppose you have 5 chairs. 1, 2 chair, 3, 4, 5. Here, for the first chair, 6 can be sitting. For the second one will be 5. Here for the third one will be 4. The fourth one will be 3. Fifth one will be 2. Here, if you have if we change 5 chairs to 6 chairs. If we change the 5 chairs to 6. Then you will have here 6. Here, in how many ways? This is 1. Number of ways, will be 6 factorial, which is 6 by 5 by 4 by 3 by 2 by 1 ways. Then we return back to the theorem number 1.4. Suppose you have, as previously I write it, 6 children but 5 chairs. The number of permutation in distinct objects taking R at a time, which is B in R, n factorial divided by n minus R factorial. Notice that R cannot be greater than n, since the factorial of 0, 1. It must be n or less. يعني you cannot R be n plus 1, suppose. There is no factorial for negative. 1 factorial, 1 factorial, 1. But 0 factorial, also 1. Also 1. R between 0, 1, 2, up to n. Here, notice that I delete the proof. Here, suppose you have for example number 1.8, 4 names are drawn from among the 24 members of club for the office of president, vice president, treasurer, and secretary. In how many different ways can this be done? Which is B 24 4, which is how much? 24 factorial divided by 24 minus 4 factorial. It will be 24 factorial over 20 factorial. You can open here 24 by 23 by 22 by 20 22 by 20. I will here equal 24 by 23 by 22 by 21 by 20 factorial over 20 factorial. Cancel this with this. You will have 24 by 23 by 22 by 21 ways. This is the solution that he solved it. Here, return back here to example number 1.9. 1.9. In how many ways can a local chapter of example number 1.9, in how many ways can a local chapter of American Chemical Society schedule 3 speakers for 3 different meetings, and how if they are all available on any of 5 possible days. Here you will have B, B, 5, 3. You will have here 5 factorial over 5 minus 3 factorial. You will have 5 factorial over 2 factorial, which will be 5 by 4 by 3 by 2 factorial over 2 factorial. Cancel. You will have here how much? 60 ways. I will stop here after in order to record another video, and next video I will continue the circular permutation. Thank you very much, and see you in the next video.